Hello everyone, I'm Professor Byung-Wol Choi at the Yonsei University in Korea. Welcome to my two-day crystal sinus augmentation course. Today is day one. On day one, I'm going to talk about a crystal approach technique for sinus bone augmentation. Next time, day two, I'm gonna talk about sinus graft material for the crystal approach. First, I want to ask you, do you think it is possible to perform 100% crystal approach technique for sinus bone augmentation? I hope you will find the answer at the end of my presentation. What is crystal sinus bone augmentation? This shows the maxilla. The crystal sinus augmentation method is by using a small hole in the crestal alveolar area. You can achieve bone augmentation in the maxilla. If you look at the literature about the crystal approach technique, by and large, they suggest that you can apply the crystal approach technique in the case of having more than 4 millimeter residual bone height. Today, I'm going to show you how to apply the crystal approach technique in any sinus augmentation case. I'm going to show you how to apply the crystal approach technique in the case of thin residual bone, such as 1 or 2 millimeter residual bone height. I'm going to show you how to apply the crystal approach technique in the case of having no residual bone on the sinus floor. How to apply the technique in the case of having a septum in the maxilla, having a thickened sinus membrane, or having a pseudocyst in the maxilla. First, let me show you the procedure for the crystal approach. There are several key factors for the crystal approach technique. Let me show you each factor. First, the key factor is digitally planned guided surgery. If you control drilling depth manually without using a surgical guide, there is a high risk of perforating the sinus membrane. You can't stop the drill at the moment when the drill penetrates the last bone layer of the sinus floor. You will get suddenly drawn into the sinus cavity, and then populate the sinus membrane. Therefore, you need to control the drilling depth using a surgical guide and a drill stump. To control the drilling depth precisely, you need a digital planning using CBCT and intraoral scans. Using the digital planning, you will get a precise information on how to approach the sinus floor. You can design and fabricate a surgical guide. Using the surgical guide, you can control the drilling depth precisely. The second key factor for the crestal approach is hydraulic pressure. You can elevate the sinus membrane by injecting a small amount of water. You just need 0.6 milliliter of saline to elevate the membrane. You can see here, the membrane is being elevated by injecting the small amount of water. This method is very safe because the water you inject into the sinus cavity goes everywhere. It's distributed evenly in the sinus cavity. Then the membrane is being elevated by the evenly distributed pressure. If you apply a localized pressure, there is a high risk of perforating the membrane. If you use the evenly distributed pressure, it's a lot safer. You can inject saline using a disposable syringe. You don't need such a device to inject saline into the sinus cavity. With this disposable syringe, you can apply sufficient pressure to elevate the sinus membrane. You can see here a nozzle is inserted into a drill hole and then injecting saline into the sinus cavity. The next key factor is membrane integrity test by aspiration. You can test whether the membrane is intact or perforated immediately after elevating the sinus membrane. If you can suck the water you injected, it suggests that the membrane is intact. You see here, pulling out the water you injected, and then you will get feeling of negative air pressure. It suggests that the membrane is intact. If the membrane is perforated, air bubbles are coming out through the tube. You can't get the negative air pressure. It means the membrane is perforated. This membrane integrity test is a very reliable method. You don't need to use this Valsalva test, which is not 100% reliable. The next key factor for the crestal approach procedure is using a dome-shaped crestal approach bar. This is the dome-shaped crestal approach bar, which is called also a sinus drill. This sinus drill has a round tip, which has a smooth cutting blade. Therefore, even though the drill touches the membrane, it doesn't damage the membrane. Using the sinus drill, you can eliminate the bone on the sinus floor. Let me show you another type of sinus drill for the crystal approach, which is available on the market. This sinus drill concept is making an island of the bone and elevating the sinus membrane. If you use the sinus drill on the flat surface, you can make an island of bone and you can elevate the sinus membrane. This shows an island of the bone you can make using the sinus drill. But if you use the sinus drill on the steep bone surface, there is a high risk of perforating the sinus membrane because you can't make the island on the steep bone surface. If you use this round-shaped sinus drill, if you use the drill on the steep bone surface, you can elevate the membranes more safely. Some people use the osteotome technique, where a fractured bone plate is pushed upward with the osteotome. One of the biggest problems with the procedure, with the technique, is this one. Your patient feel head strike impact while manipulating the osteotome with a hammer. It's a terrible experience for your patient. Another problem with the technique, with the osteotome technique, is you can see here, I try to elevate the membrane with osteotome, but the membrane was torn. It is not a safe method for elevating the sinus membrane. Let's move on to another key fact for the crystal approach: a low-speed drilling. When you penetrate the sinus floor, you should rotate the burr as low as possible, less than 10 RPM. It's very important to keep the membrane intact. If we use 100 RPM drill speed, you can increase the friction between the drill and the sinus membrane. And then it makes the membrane fragile. It makes the membrane easy to return. And then when you inject saline, the membrane is perforated. Therefore, you should rotate the burr as low as possible. Then you can elevate the membrane more safely. It's very important to keep the membrane intact. Don't make the membrane weak by using high speed. If you use a low speed, you have to use a strong force. You have to apply force to the drill. You have to push the drill upward with force to penetrate the hard sinus floor. You need a strong force rather than a speed. The force you apply is controlled by the surgical guide and a drill staff. Let me show you the procedure step by step. The first step is a tissue punch. A tissue punch is used to remove the soft tissue at the planned implant site. The next step is implant osteotomy is performed up to 1 millimeter short of the sinus floor. Then sinus striae is used to eliminate the last bone layer of the sinus floor at a low speed. Next step is the membrane is elevated by injecting saline, a small amount of water. After elevating the sinus membrane, you need to pour out the water you injected to test the membrane integrity. And then the next step is very important. When you look at the opening hole after penetrating the sinus floor, the opening hole of the sinus floor is too narrow to insert a graft material. As a result, you need to expand the opening hole by advancing the sinus striae further into the sinus cavity. You need to control the drilling depth precisely by using a surgical guide and a drill stump. By advancing the sinus striae further into the sinus cavity, you will get this enlarged opening hole on the sinus floor. The next step is to check whether the opening hole of the sinus floor is completely clear. After checking the opening hole, sinus graft material is inserted through the drill hole into the sinus cavity. You see here, placing graft material into the hole, pushing the graft material into the hole. When you push the graft material into the hole, the material is likely to go upward, not in all directions. Generally, they go upward. Therefore, you need to spread the material. You see here, spreading the graft material. And then, finally, you can place an implant into the sinus. Then you will get this dome-shaped graft material around the implant in the sinus cavity. Let's have a look at a steep sinus floor case. When you approach the steep sinus floor, you need to approach the sinus floor differently. Because with the same drilling depth, the opening hole is different. Therefore, you need to advance the sinus striae further into the sinus cavity. Sometimes you need to advance the sinus striae additional 2 millimeters into the sinus cavity. Let me show you the procedure. After using the sinus striae up to the sinus floor, the membrane is try to inject saline to elevate the sinus membrane. If you are not able to inject the saline into the sinus, you need to advance the sinus striae additional 1 millimeter. After advancing the drill additional 1 millimeter, try to inject saline into the sinus cavity. If you can't inject the saline into the sinus cavity, you need to advance the drill additional 1 millimeter. If the sinus floor is opened, then the saline will go upward along the slope. In this condition, if you put the graft material into the sinus cavity, the material will also go upward along the slope. It is not ideal. To prevent this from happening, you need to enlarge the opening hole on the sinus floor further by advancing the sinus stream. After enlarging the sinus opening hole further, the graft material is inserted and spreaded. Then you will get this dome shape of graft material in the sinus cavity. Let me show you this case, a slope sinus floor case. An implant was planned. This is immediately after sinus bone graft and implant placement. You will get this, you see here, a dome-shaped bone formation around implant. This shows very good dome-shaped bone formation around implant using the crestal approach technique. Let me show you another case where more than 2 implants are installed in the same maxillary sinus cavity. If you place more than 2 implants in the same maxillary sinus, the saline you inject through the second drill hole, the water is coming out through the first drill hole. As a result, you can't suck the water. You can't test the sinus membrane integrity by aspiration method. How to solve the problem? Let me show you how to overcome the problem. After using the sinus stream up to the sinus floor, the membrane is elevated by injecting saline at the first implant site. A sinus graft material is inserted at the first implant site. Implant is placed at the first implant site. After completing bone graft and implant placement at the first hole, then move to the second hole. After drilling, saline is injected, graft material implant is placed at the second implant site. Then you will get this dome-shaped graft material around each implant. You will get this dome-shaped bone formation around each implant using the technique. Let me show you this case. 3 implants are planned to be placed in the same maxillary sinus cavity. This is immediately after sinus graft and implant placement. Look at that, 6 months after the procedure. Good bone formation around implants, you can see. let's move on to challenging cases for the cluster approach technique and how to overcome those challenges. The first challenge is a very thin residual bond, such as having 1 or 2 millimeter residual bond height. If an implant is placed in the thin residual bone area, the implant is likely to migrate into the sinus cavity. Let me show you this case. You see here, 3 implants were placed. One of the implants, the most posterior implant, moved to the sinus cavity. Finally, the implant dropped into the sinus cavity. The doctor who performed the procedure told me that he did nothing with the implant after the procedure, but the implant spontaneously moved into the sinus cavity. The posterior implant, which was placed in the thin residual bone area, moved into the sinus cavity. Let me show you another case. Look at the middle implant. The middle implant moved to sinus cavity spontaneously. I think that the sinus cavity is like a black hole. It pulls the implants. It draws the implants into the sinus cavity like a black hole. What is the solution for that problem? First, you need to perform a lot undersized drilling. This slide shows the undersized drilling in the thin residual bone case. The implant diameter, look at that. The implant diameter is 5.0 millimeters. The final drill size is 3.2 millimeters. The final drill size is a lot narrower than the implant diameter to achieve initial implant stability. In the thin residual bone case, you need to control drilling depth precisely. Otherwise, you can perforate the sinus membrane. In the thin residual bone case, you need to control the implant depth precisely. Otherwise, you can drop the implant into the sinus cavity. This shows an implant connector which has a stopper. It helps you control implant depth precisely. You can see here the connector. The stopper of the connector controls the implant depth. Generally, there is a hard bone on the sinus floor. The remaining bone in the maxilla could be one of the hardest bone in the maxilla. The bone is very hard. Therefore, there is a high possibility to get initial implant stability, even though bone is thin. If you use a low speed together with a surgical guide, your drilling becomes a lot stable. Therefore, there is a high possibility for you to get initial implant stability. If you connect a healing abutment to the implant that is placed in the thin residual bone area, it is likely for you to drop the implant into the sinus cavity. Therefore, we prefer using customized abutment rather than healing abutment. You may be concerned about how to fix the customized abutment with a high torque. You need a Ziegler. Using the Ziegler, you can connect the abutment correctly and fix the abutment with a high torque. It prevents the abutment from rotating. This is the mechanism of the Ziegler. Using the mechanism, you can fix the screw with a high torque. The two implants that are placed in the thin residual bone area are splinted together with a prefabricated provisional bridging. You see here, two customized abutments that are connected to the implants that are placed in the thin residual bone area, and the provisional bridge connect them together. It's very important to make the crowns out of contact with the opposite teeth to avoid loading to the implants. You see here, two implants are planned to be placed in the thin residual bone area. I don't like planning like this. Instead, we prepare planning like this. One of the implants is planned to be placed in the thick bone area to achieve initial implant stability. Then the two implants are split together with the provisional bridge. This is immediately after the procedure. You see here, one implant in the thick bone area, and the other one is in the thin bone area, and then they are splinted together with a customized abutment and a provisional bridge. This is 6 months after procedure. This shows 6 years after procedure. You can see here very stable bone formation around the implant. You can see here the healing process after the procedure. we applied this technique to 33 patients who had a very thin residual bone height. In all patients, they have a very good dome-shaped bone formation around the implant. It was a very successful procedure. Let's move on to the next challenging case, which is the case of having no residual bone on the sinus floor. Do you think it's possible to elevate the sinus membrane in the bone defect area? In the beginning, before trying the technique in the patient, I thought that it might not be possible. Let me show you my patient that I performed the crystal approach technique in the patient. Let's have a look at this patient. This site, no residual bone on the sinus floor. We planned 2 implants. We avoided the bone defect area. We planned to place in the area where there is more bone. We planned immediate restoration. And then we prefabricated a customized abutment and a provisional bridging. Let me show you the procedure. At the 1 implant site, after using sinus 3 up to the sinus floor, and the membrane was elevated by injecting saline at the site, and then a sinus graft material and implant was placed. After completing the implant placement at the site, we moved to another site. After drilling, the membrane was elevated, and then graft material and implant was placed at the second implant site. This is immediately after the procedure. Look at the sinus membrane. Look at the membrane elevated in the bone defect area. You can compare before and after the procedure. You can clearly see that the membrane was elevated safely in the bone defect area. This shows 6 months after the procedure. Very good bone formation around the implant. Let's have a close look at the bone defect area. You see here, the membrane, immediately after the procedure, the membrane was elevated. 6 months after the procedure, the membrane was more elevated. And then below the elevated sinus membrane, there was bone formation. When it comes to the elevation of the sinus membrane in the bone defect area, we think that the force generated by the graft material and the implant might have played a great role in elevating the sinus membrane in the bone defect area. Let me show you another case. You see here, no residual bone on the sinus floor. No bone on the sinus floor. We planned 3 implants. 2 implants were planned to be placed into the sinus area. This is immediate after the procedure. You can see here, the membrane was elevated in the bone defect area. Let me show you another case. No residual bone on the sinus floor. We planned implant planning like this. Immediately, you can see here, the membrane was elevated. Let me show another case. no residual bone, implants were placed. You can see here the membrane was elevated in the bone defect area. 1 year. These cases show that you can elevate membrane in the bone defect area as well. Let's move on to the next challenging case, which is the case of having a thickened sinus membrane. In the thickened sinus membrane case, you can also elevate the membrane through the crestal approach. Let me show you the procedure. First, a tissue punch is used, and then implant osteotomy is prepared. The sinus floor is penetrated by the sinus drill, and then the membrane is elevated by injecting saline. When you inject saline, you need more pressure to elevate the thickened sinus membrane. After elevating the sinus membrane, sinus graft material is inserted through the drill hole, and an implant is placed. Let me show you this case, who has about 19 millimeter membrane thickness. Let me show you the procedure, how to perform the crestal approach technique in the case. This shows immediately after implant placement and sinus graft. This shows 3 months after the procedure, 3 years after the procedure. Look at the membrane thickness before the operation, 19 millimeter thickness. 3 months after procedure, 16 millimeters. 3 years after procedure, the membrane thickness decreased down to 12 millimeters. This case shows that if you perform the Crestor approach technique, it doesn't increase the membrane thickness. Let me show you another case. You see here, thickened sinus membrane, especially in the molar area. This is immediate after the procedure, 6 months after procedure. You can see the healing process. It shows that you can elevate the thickened sinus membrane, sinus graft, and implant placement simultaneously in the case of a thickened sinus membrane without evidence of sinus mucosa thickening. Let's move on to another challenging case, which is the case of having a pseudocyst in the maxilla. In this case, you can perform cyst removal, sinus graft, and implant placement simultaneously through the Crestor approach. Let me show you the procedure. A tissue punch is the first drill in the sequence. Implant osteotomy is prepared up to 1 millimeter short of the sinus floor, and the remaining bone is removed with the sinus drill. The membrane is elevated by injecting saline. After elevating the sinus membrane, the cystic fluid is aspirated through the drill hole with the syringe. After emptying the cyst cavity, a graft material is inserted, and then an implant is placed. Look at that. Before and 1 year after the procedure, the cyst was gone. This is before, 1 year after. The cyst was gone. Before, 1 year after, cyst was gone. All these cases show that you can perform cyst removal, sinus graft, and implant placement simultaneously through the Crestor approach in the presence of cyst. Let's move on to the next challenging case, which is the case of having a septum in the maxillary sinus. If there is a septum in the maxillary sinus, if you perform a lateral window approach technique, there is a high risk of perforating the sinus membrane, even though you have a lot of experience with the procedure, because it's extremely difficult to perform the lateral window approach technique in the presence of antral septums. If you perform the Crestor approach procedure, it's a lot simpler, a lot safer, a lot faster. You can approach the sinus floor away from the septum. You can elevate the membrane away from the septum. The septum actually helps you shape the graft material in the sinus. How could we make this shape of bone formation in the maxilla without a septum? The septum works as a wall to make bone in the area, in the maxillary sinus. let me finish off my presentation. Today, I have been talking about how to apply the crystal approach technique in challenging cases, such as having a very thin residual bone, having no residual bone on the sinus floor, in the case of having a septum in the maxillary sinus, in the case of a sloped sinus floor, having a thickened sinus membrane and a pseudocyst. I believe that now you think that it's possible to perform 100% cranial approach for sinus bone augmentation. Actually, we don't need the lateral window approach technique anymore, because we can apply the crystal approach technique in any case of sinus bone augmentation. Thank you so much for joining my 2-day crystal sinus augmentation course. I hope you've learned a lot for improving your crystal approach technique. I hope you will join again the next course. See you soon again. Bye.